In this video, I'll show you another integral using substitution, but this one will require two special things. So one, we're going to have a little bit of an issue with the constant here because the derivative of the inner function isn't exactly showing it up out in front. So we'll have to do a little bit of a tweak. And then also this is a definite integral. So we're going to have to see how that plays with substitution. Okay, so for substitution, again, the first thing I think about is what's the most complicated part, which here would be the square root of something. And does that derivative show up on the outside being multiplied? Well, if I have x squared minus 1, the derivative of that is 2x. I don't have a 2x out here, but I have something that's almost 2x. It's just missing a constant. So what I'm going to do is I'll make u equal to x squared minus 1, and then du is 2x dx. And now because I don't have 2x dx, I have x dx. I'll move this 2 to the other side. So I'll say, okay, 1/2 du is equal to x dx. So when I go to replace the x dx part, I'll replace it with 1/2 du. Okay, so when I integrate now, I get 1/2 and then square root of u du. And here's the thing, because this is a definite integral, these are the limits for x. So x equals 1 to x equals 4. Well, I'm not dealing with x anymore, I'm dealing with u. So I need to think about, okay, when x equals 1, u is equal to 1 squared minus 1, so 0. When x is equal to 4, u is equal to 4 squared minus 1, which is 15. So these become my new limits of integration. Okay, excellent. Now to integrate this using the power rule, I usually prefer to rewrite my square root u as u to the 1/2. So then now when I use the power rule, I'll think about this as 1/2 u to the 3/2 divided by 3/2, right? I add 1 to that power. And now I'm evaluating this at u equals 0 to u equals 15. So before I evaluate that, in this case, I think it's worth simplifying a little bit. So if I think about pulling this up here, it becomes 2/3. So this will end up looking like 1/3 u to the 3/2 from 0 to 15. And now when I plug in those limits, I have 1/3 15 to the 3/2 minus 1/3 0 to the 3/2, which is just 0. Right, so my final answer, what I'm left with, is 1/3 15 to the 3/2. So notice here that when I'm doing substitution with a definite integral, I don't need to plug u equals x squared plus minus 1 back at the end after I found the antiderivative. And the reason for that is because I've already changed the limits of integration. These are in terms of u now. So with a definite integral, there is this extra step of changing the limits of integration, right? Right when you do the substitution. But then at the end, you're saved a little bit of time because you don't have to sub u equals, in this case, x squared minus 1 back into the original function.